हो रहा है ना चालू।
चल रही है। इसका माइक्रोफोन ऑन करो।
So is my screen visible to all of you? बोल।
इसका वीडियो ऑन करते हैं ऐसा दिखेगा।
So let us start. Today we will discuss some linear system and their solution and how these methods work in the techniques for the numerical algebra. Here we shall be discussing Gaussian elimination method and some subsequent methods which are just uh, advancement of Gaussian elimination. Yes, Mr. Jyoti Datta. Mm-hmm. Oh, okay. Sure, sure, sure. Sure, sure. Okay. Okay. We can whenever they will come, we can be discussing them. Okay. You just tell me if something is not clear to you, and then we will discuss. Is that fine by you? Good. Oh, okay. 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 So let us then start with this notational section. So first comes the set of natural number. It is just the set of natural number, nothing. So this is some double n, like n with one more line. Then we have this. This is the set of integer. It is 0. Then plus minus 1. Plus minus 1 means 1 as well as minus 1 is included. Okay. So on and so forth. Yeah. Third is, let me just see the layout first. Yeah. Then third will the set of real numbers. This is the set of numbers. Then probably we might use this. Then this is the set of rational numbers. It's Q. So you write Q and then you put one line. Okay? You write Q, then you put one line like this. Okay? Yeah. So this is the set of rational number. Yeah. Then set theoretic notation also let us fix. uh, set theoretic notations. So basically, this means for all. Okay, am I audible? Now this means there exist. Now this, sometimes this double colon or this means such that, is there something else that I might forget? So let us use it in a sentence, all these things, then we'll be clear. Yes. Yeah. So this means belongs. So do not confuse. I write epsilon like this. Okay. So do not mix with this. This is epsilon. This is belongs. Then this is contained. Then of course we have this. It means does not belong. And of course we have this also. What should it mean? Can anyone tell me? What should it mean? Yes, does not. So, so this is contained, and this means does not contain. Okay. If there are any other notations that we have forgotten here, we will see when we come to that. Okay. So don't worry. You just, and I really appreciate you telling me that, and that's what I have been asking since day one. Just whatever doubt you feel, whatever doubt you have, however trivial you may think it is, just ask. Okay. Now I am writing one sentence, and you tell me what will it mean. Okay. Yeah. Can anyone tell me uh, what does it read? Yes. How about others? Is it clear to all of you? There was someone who asked them this confusion he had. Okay. Oh, one is Biswajit and one is Biswajyoti. Okay, I will remember. Okay. So it just reads for all epsilon greater than zero. Someone joined. There exists delta greater than zero such that mod of fx minus fy is less than epsilon whenever mod of x minus y is less than delta. Correct? Okay, so all of us know this. Now let us start. Now, because I think we should discuss it again. So, metrics technique in numerical analysis. This we will discuss. Again, if you have some doubt, please tell. So, what have you learned so far in your course of numerical analysis? Can anyone tell? I was just asking, what are you studying in your course of numerical analysis in the NPTL course? Okay, good. Good. Hmm. So here we see the fundamentals of linear algebra that are used in the numerical analysis. Okay. For example, in the last class we saw the fundamentals of real analysis that are used in numerical analysis. So there is another section that is used heavily in numerical analysis, and that is precisely the linear algebra part. Okay. So let me put it this way. We all know what is the general form of n cross n system, right? So if you have an n equation in n variable, how will it look like? Yes, n linear equations in n variable. So it must be of this form, right? A11 x1. This is my first equation. Some x2 plus a1 and xn. So what are my variables? Variables are precisely x1, x2, and up to so on and so forth. These are my variables. And the second equation will be of the form some a21, then a22 x2. And you keep on doing this. This dot 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 means there are many equations which we cannot write because we don't know what is n. Okay? So we just put these three dots. So this will be an1, x1, an2, x2. Yeah. So this is called, how many equations are these? So, yes, so this is E1, this is E2, and this is En, which means n equation, nth equation. Okay. Now you might ask, why do we study it? So linear equations arise very naturally up until you must be knowing this, right? Do we need to have the motivation here? If you say, then I will give some very basic one also. That why do we need to learn how to solve a linear system? You must have seen it in your class 10th or 12th. There are many questions in nature that involve linearity. And that is where linear equation comes. For example, we used to learn this x comma y, right? With variable x, y, we used to learn how to solve this linear equation. Am I correct? You have to say some yes or no because I cannot see your faces. So I always rely on your voice. Oh, is it? Okay. No, I was just asking where does this linear equation come from? Can anyone give me one example where we see linear equations? Mm-hmm. Okay. And what will be that?
We can solve that. What is the solution for
Yeah. For example, if you have these two lines, you know, let us say this is one line, and let us say this is another. Correct. Now I want to find the intersection of these 2 points. Now, what will be the intersection? Which lies on both the lines. Correct. If this line has equation, what is the standard equation of line? Ax plus by equal to c. Correct. And let us say this line is alpha x plus beta y equal to gamma. Then the intersection of these two lines. Okay, let me write example. So the intersection point, let's say intersection point is this P comma Q. So this intersection point P comma Q, it satisfies this, right? Satisfies ax plus by equal to c and alpha x plus beta y equal to gamma. Now, when you solve this, because the line that we have drawn, they have a solution. So this will have some solution, correct? Depending on the values of A, B, C, alpha, beta, gamma. So this is one example that comes from the geometry. Okay. And indeed, we will see that there are many natural phenomenon which involves the system of n linear equation in n variable. And these are of the simplest equation. Anyhow, if you want to solve a system or if you want to solve an equation, we know what is the simplest of all. Correct? The simplest equation will be where there are no powers. As soon as, let's say, if I'm taking x square plus y, okay, which one is easy to solve? You tell me. X plus y equal to 0. Which one is easy to solve? This equation or this equation? Okay, let us say. First one, right? Because this is a linear equation. Linearity is the easiest of the equations that you will always encounter. So if we really want to learn how to solve any system of equation, the first step should be what should be the natural first step? The linear equation, correct? Yes, sir. I mean, I can always say this, like sine xy equal to 0. This is also an equation, correct? But this is again more complicated than the previous two. So, what do we, whatever you learn OD, PD, real analysis, operator theory, numerical analysis for that matter, or even some of the very abstract subjects, you will have to encounter solving equations. You have to do. At one point of time, when you're learning mathematics, you have to learn how to solve equations. Now, if I want to learn something, I should start with the basics, correct? And the basis of solving any kind of equation is the linear system of equation. And that is what we will do. That is what happens here also. This you must have already seen in the previous lectures. Now, if I ask you, can you convert this system? So let us call this as a system. Can you convert this system into a matrix equation? And how will you do it?
The left-hand side is product of two matrices, one
Mhm.
square matrix A, another column matrix exponential
Okay.
right.
Okay. Yes, that is correct. Let us see what is being referred. Yeah. So if I so this is my given system of equation, right? Here here the coefficients Aij and Bj are real numbers. Now what is our aim? Our aim is to find our aim is to find the values of x1, x2 up to xn such that the above system holds true. Correct? This is my aim. All of you agree with this? Yes. So as Biswa suggested, we can convert it into a matrix equation like this. You just write down the coefficient one by one. Okay, someone joined. Yeah. And this will be the vectors. These are the unknowns. These are the variables. And this will be the data on the right hand side. V1, V2. So just take your time, all of you, and check. If you multiply this matrix on the left hand side, do you get the left hand side of this? All of you agree with this?
Yes, sir. Yes, sir.
Yeah. So we write this system as, you know, so we write this system as A, which is an n cross n matrix, correct? Then this is denoted by X, which is my n cross 1 matrix, or we can denote it by small x also, and then we denote it by b. Now when I write a bracket, this notation means A is a matrix of order n cross n. Okay, this is the order of matrix. What is the order? The first denotes the number of rows, so this denotes number of rows, and this denotes what? Columns. Okay. So as you can see, we have converted linear system into system of matrix equation, right? This is a matrix equation. Yeah. Okay. So what are the known things in this in this system? This is a matrix equation. Very good. Matrix system or equation. Yes, you are correct. A and B are known. So here, remark one. The known things are this is A and this small b, correct? And what is unknown? X. Yeah. What will be the easiest thing? If so, we are given ax equal to b, and this A is a square matrix. You can see. Now, if let us say A is invertible, let us suppose A inverse exists for the time being. It need not exist, but let us suppose for the time being it exists. So then, what I can write Ax equal to B, then I can multiply pre-multiply A inverse. Am I correct?
Yes, sir.
And because matrix multiplication is associative, I can change the bracket. So this will just give me x equal to A inverse. Am I correct? And because B is known and A is known, so A inverse is also known. So we are able to compute x. The aim is, what is the aim? Our aim is to find x. So then x is given here, right? A inverse B. Am I correct? So, so whenever A is in invertible matrix, then this is the easiest of the case to solve a system. As you can see from what we have just discussed. So, and does anyone know what are the criteria to check whether A is invertible or not? Yeah, that is one of the easiest criteria, right? So there comes the theorem from linear algebra. Ax equal to b when A is theorem. Let A be an n cross n matrix, then Then the following are equivalent. Number one, determinant of is non-zero. Then Ax equal to b. How many solutions this should have? If we know determinant A is non-zero, so how many solutions this system Ax equal to b should have? There are three choices. Either there is no solution, or there is a unique solution, or there are infinitely many solutions. Tell me. Yes, it has only one solution, which means unique solution, right? Ax equal to b has a unique solution. A inverse b. The solution is given by, so I will write it in the bracket. A inverse b for every b in Rn. Okay. Third will be, if x equal to 0 and a is invertible, then what should be the value of a? What should be the value of x? If x equal to 0 and a is invertible, then x should be 0. Yes. And finally, a is. Do you know what is invertible mean? Yeah, what does it mean? Which means there exists some b such that AB very and this B will denote by inverse. Yes. This is what we mean. Can everyone prove this part? If I ask you to prove it, can you prove it? Everything. Okay, can you prove 4 implies 3? Quickly, open your notebook and take your time and prove 4 implies 3. So, please prove 4 implies 3. This is easy, right? 4 implies 3. Yes, yes. This is easy, right? Because A is invertible. How many are others there? How many are there? Anuj, Anjali, Biswajyoti, and how should I pronounce your name? Bala. So all of you, can you prove 4 implies 3? This is not difficult. And we just even discussed it, right? So can I write it as an exercise? So you just what you do, you take what you take x equal to 0. And what do we have to show? X equal to 0. Now when Ax equal to 0, then pre-multiplying A inverse both sides. Correct. What do we get? We get A inverse A equal to A inverse C. So what is the left hand side? It is X. What is the right hand side? It is 0. So hence we are done. Now what about 3 imply 4? What about 3 imply 4? Which means what you have, you are given that. What is your given hypothesis? What is your given hypothesis? That Ax equal to 0 has a unique solution x equal to 0. Has only the 0 solution. Correct? This is the hypothesis. Let us go back to third. Third says Ax equal to 0 implies x equal to 0. Which means whenever Ax is 0, x equal to 0 is the only solution. There are no other solutions. Okay? Now what do you have to prove? You have to show, what do you have to show? That there is a matrix B such that what happens? AB equal to I equal to BA. Am I correct?
Yes, sir.
Yes. Now how do you prove that? So let us start. So this is a standard notation, but I will write it. So let us define E1 to be. You know this standard notation E1? 1, 0, 0, 0. What should be E2? Yes. 0, 1, 0, and 0. And what is N? It is 0, 0, last component 1. Correct. Does anyone know any special property of this? These are the bases of Rn. Am I correct? Yeah, okay. Now what I'll be doing, I'll be breaking this proof into several steps, and I will ask you to prove it right here, right now. Okay? To show me that Ax equal to E I has a unique solution, has a unique solution for each I, for every I equal to 1 to up to n. What am I asking? What am I asking? That you prove that this system Ax equal to Ei, it has a unique solution. Can you prove that? So how do you start? You start that let there are two solutions, right? Let there be two solutions. Am I correct? There be two solutions x and y. What does it mean? It means
Contradiction.
yes, yes. It means Ax equal to Ei and Ay also equal to Ei. Now I am giving you some 3 minutes. You think of it and then you tell me. Okay? So are you done? Take your time. What do you have to show? Unique solution, which means you have to show x is equal to y. So try to show that. No, it is just whenever ax is 0, which means if there is some x such that ax is 0, then x has to be 0. So okay, let's do this. So can I say from this then ax equal to ay? Can I say this?
Yes, sir.
Then can I also say this? Ax minus ay is 0. Then if I take a common, not common, I would say, then this thing will happen, right?
A is multiplied by x minus y.
Yes. Now we know whenever a some vector is 0, then that vector has to be 0, right? See, what do you have? Whenever you have av equal to 0, what it should imply? This is given. Whenever whenever av is 0, by given hypothesis, v has to be 0. Am I correct? So here what is, so here you see a of x minus 1 is 0. So what does it tell about x minus 1? Yes. That x minus y has to be 0, and this follows, yes, and this follows from the given hypothesis. So this implies x equal to, so now this ax equal to ei, it has a unique solution, correct? All of us agree with this? Okay, so step 2, step 2, let x1, x2, xn be such that ax1 is e1, ax2 is e2, which means these are the unique solution of ax equal to ei, correct? All of you agree with this? Now let us define b. Step 3. Yeah. So define a matrix b. B, you just take this as the vector. B to be, x1, x2, xn. So remember x1, x2, xn are column vectors, correct? So what is the size of B? Can anyone tell? What is the size of B? Is it n cross n matrix? Yes. Now if I ask what is A times B, what will be A times B? So remember A is this and B is this matrix. If you follow the principle of matrix multiplication, then you will know that the first column of this matrix will be AX1, the second column will be AX2, and third column will be AX. Okay, is it clear? Do you know this? Do you agree with this? If not, then I can explain why. Please tell me if this is clear. Yes, this is just matrix multiplication. See, whenever you have some matrix A and you have some matrix, let's say B, or A, B would be too confused. Let's say you have P and Q. So then, let us take 2 cross 2 example, then it will be easy to check. You know, P11, P12, P21, P22. Correct? And Q will be Q11, Q12, Q21, Q22. Now, what is the first column? It will be P11, Q11 plus P12. Sorry, uh, tell me P21, Q11. What am I doing? Just a minute. Sorry. So the first entry will be P1. Yeah, yeah. And this will be P21, Q11 plus P22, Q21. Correct? And then similarly, here you will have your second column. Am I correct?
Yes, sir.
Now, if you there is an alternative way of seeing this. You just tell me what will you get if you multiply P with the first column of Q. So I am saying this will be a first column. Okay, let me just say. What is P times the first column of Q? Can anyone tell? It will be you're just multiplying this matrix with this. Correct?
Yes, sir.
So this will come out this only.
Hmm.
So basically, this matrix is nothing. This matrix I can write it as P times P times x1, and this will be P times x2, where x1, x2 are where x1, x2 are the columns of Q. Am I correct? Yes or no? X1 here will be Q11, Q21, and X2 will be Q12, Q22. So you see, whatever we have written here, then is it's correct, right? This step is correct. The first column of AB, how will it look like? You just multiply B with A. In the sense, the first column of AB will be obtained as you multiply A with the first column of B. You will get the first column of AB. You multiply A with the second column of B, and you will get the second column of AB. Am I correct? Is it clear? Now, what is AX1? Can anyone tell me by given hypothesis? But we have not hypothesis, but we have proved. Remember step 2. What is AX1?
E1,
E1, right? And then this will be E2,
E2,
and then this will be
EN.
EN. Correct. So, what does this matrix represent? Remember, E1 was the first entry 1 in rest of December 0. E2 was 0, 1, 0. So, and the last column was 0, 0, 0, and here it will be 1. So, what is this matrix?
Identity matrix.
Very good. This is identity matrix of n cross n order. So, what does it prove? That A has left inverse or right inverse?
Inverse.
No, for inverse we need
Right
BA
inverse.
right inverse. Correct. So we have that A has right inverse. So what do we have to show now? We need to show that BA equal to identity. Am I correct? Yes or no? Yes or no?
Yes, sir.
So can you prove it? Please prove it. Take your time. See, we all are here to learn. Someone asked me last time. I think it was the only how do we know what to prove, how to prove. Correct?
Yes, sir.
This is how exactly we prove. You just take some guess and then you start working on this. So let me give you some hint here. Can you first prove step one? Can you prove that Vx equal to 0 imply x equal to okay? Let me write. Whenever BV equal to 0, we have. Can you prove this first step? Can you prove this first step?
Since B is a non-zero matrix, we
No,
should
B is a matrix such that AB is equal to identity. We have proved this. No? B is not any arbitrary matrix. B is a matrix such that AB is equal to identity. Now you start with B equal to 0. You have to prove that B equal to 0. How will you do that? You just multiply A both sides.
yes.
take your time. All of you, please take your time. And if it is not clear, then tell me. Okay? Is it clear to everyone? Okay. Please. Okay. Am I going too fast? Please tell me. Am I going too fast? Okay. So whenever b equal to, so you let, okay, let us do this. Let b equal to 0. Then we know you just multiply a both sides. A, b, sorry, not b inverse. We do not have b inverse. We have a. So you multiply both, yeah. So it will be a upon 0, correct? But yes, it will be equal to I times b, and this will be 0. Yes. So this will imply b equal to 0. Yes. And this, yes, you can mute your mic. Very good. So this happens because AB is same as identity. Now, whatever, so B is such a matrix that whenever B is 0, B has to be 0. So can I do the same process here again for B? You remember A has such a property in the beginning. Then we constructed, then we constructed right inverse of B. Am I correct? Right inverse of A. Yes or no? You see, in the start, how did we start? A was a matrix such that 0 is the only solution of Ax equal to 0. Using this piece of information, we constructed a matrix B such that AB equal to identity. Yes or no? So can I do the same process for B? Can I do the same process for B? So repeating the argument, can I say there exists an n cross n matrix C such that such that B C, okay, let me put it such that B C equal to identity. Can I do this? Yes or no? Okay, I think you have got confused. In the beginning, what did we have? A b equal to 0 imply b equal to 0. We started with this hypothesis. Then we constructed B such that A b equal to identity. Am I correct? Yes or no? Now you just see here for B also we have this information. Na? B equal to 0 imply B equal to 0. So using the same process, can I construct C such that B C equal to identity? Yes. Correct. You just replace A by B. You know, what does it say? A has right inverse. A has right inverse. So here what is it saying? B has right inverse. Am I correct? So we are doing nothing. We're just repeating the process. Please tell me if there is some confusion. Please tell me. Now you prove that. How will you prove that A equal to C? We are done if we prove that A equal to C. Yes or no? How will you prove that A is same as C? Huh? So, exactly. Exactly. So how will you prove? what do we have? Let us start with something. This we have to show. So what do we have? We have two information. AB equal to identity equal to BC. Am I correct? This we have. So if you start with AB equal to identity, and what happens if you multiply C both sides? You will have this,
Yes.
or maybe hmm, I think it's better to post multiply with C. If can I write this ABC equal to C? Can I write this? Now what is BC? You see what is BC?
Identity.
Identity. And what is A times identity? It is just A.
A.
So we are done, right? We
Yes.
are done. So therefore, what do we have finally? Therefore, A A identity and it is B. So A has same left and right inverse. So therefore, therefore, A is invert. So is it fine? Is it fine?
Yes, sir.
Now I am giving you one task. See, this is a basic linear algebra theorem, correct? But still, you know, the, we have to prove it. And you see, why is it necessary to prove this theorem? You will see when we learn the Gaussian elimination method. So can you prove 3 implied 2? 3 implied 2 is easy, right? Just take your, okay, when you sit in this 2 hours, 2 hours discussion session, do you sit with pen and paper?
Yes, sir.
All of you? All of you? All four of you?
Yes, sir.
So if I ask you to prove 3 implied 2, then please do it. You assume 3 and then you prove 2. We have already proved it somewhere. But you prove it explicitly now. 3 implied 2. You assume 3 holds and then prove 2. Take your time. Whenever someone proves it, please tell me. Okay? I'm waiting. Okay, here we something like this. You see step one. Can you see step one? Something like this. Am I audible?
Yes, sir.
Yeah. So remember step one. Let us suppose there are two solutions, ax equal to b and ay equal to b. Here, you assume that there is another solution ay equal to b. Then that is just ax. So it will imply a equal to ay. Correct? Then you will have a of x minus y equal to 0. Then from here, using 3, you have whenever some vector gives you 0, then the vector has to be 0. So here, what will you have? X minus y equal to 0. Am I correct?
Yeah. Good.
Yeah. So 3 implied 2 is easy, right? Is there someone or among four of you who has some comment or thing to say on 3 implied 2? Please tell. See, one thing I would like to say is that, there are only four of you. You can ask as many doubts. No? Why are you hesitant about asking them if they are there? Because there are already very few students. So it's not like if you ask some doubt and you will not be heard. This is the benefit of sessions where students are very like few in numbers. So please try to make the most of it. And I will also work hard to make sure that every doubt of yours is completely understood by you. So I am assuming 3 imply 2. So what about 4 imply 1? So 3 imply 2 done. I will write 3 imply 2 done. Let me just write 3 imply 2. How did we prove? Let us suppose there are two solutions. Ax equal to b equal to ay. Then ax minus ay equal to 0. Then this implies a of x minus y equal to 0. And then third implies x minus y has to be 0. So hence x is same as y. Now what about 4 imply 1? What is 4? 4 is that suppose a is invertible. Suppose a is invertible. Then what do you have to show? To show determinant of A is non-zero. How will you show that? Please show this. This is very easy. Assume that A is invertible. What does A invertibility mean? That A times something will be identity. Am I correct?
Yes, sir.
Then apply the determinant formula both sides and tell me. Take your time and prove it.
Sir, A,
Okay, okay. Let me repeat it. Right. There exists B such that AB equal to identity. Okay. Then date A is equal to data I. But data I is equal to n cross n matrix, so it has to be n, correct? Yeah, correct. Oh, sorry. Yeah, sorry, sorry. One. Yes. Very good. Data into data B equal to 1. Yes. So this automatically implies that data is non-zero. Correct? Very good. Very good. Now, what about 1 imply 4? If 1 implies 4, you have to prove. How will you do it? So you have to suppose determinant of A is non-zero. Hmm. Then what do you have to prove to show to show A inverse exists, right? Do you know this formula? A of adjoint A is actually determinant of A. Do you know this? Determinant of A times identity. Do you know this formula? This is called this is the famous name. This is called Cramer's rule, right? So if what does it say? What does it say? If determinant A is non-zero, so I can always take determinant on the other side and it will give you 1 upon determinant of A times adjoint of A is identity. Am I correct? All of you agree? So this implies A is invertible because A has right inverse and ऊपर हमने we saw in the above if A has right inverse then it has left inverse, correct? So using same thing you can always prove that A is invertible. Is there any confusion? Please ask. So this proves the theorem. This proves the theorem. How did we prove it? We proved first that 3 imply 4 and 4 imply 3. Then we proved 4 if and only if 1, 4 if and only if 1, and then we proved 3 if and only if 2. So it means each of them is equivalent, correct? Am I correct? So this is a very, very, very strong result. I mean, this comes from basic linear algebra, but as a result, it is very strong. Let us see an application of it, and which is the famous Gaussian elimination method. Gaussian elimination. So, do some of you know what is Gaussian elimination? Upper triangle.
After trying to run matrix,
Yes.
they are using backward substitution.
Yes. Correct. Yes. That is the idea. So let us do this question step by step. I will start by giving, explaining through the example because it is easier. So x plus y plus z equal to 2, then x plus 2y plus z equal to 5, then 2x plus 3y plus 4z equal to 11. So step 1, convert it into a system of metrics. Can you convert it into metric system?
Yes.
Okay, write it down. Okay, just a minute. Yeah, yeah. So this is the yeah. So what is your system? Tell me. Can you? So what am I asking? Convert. So in the beginning we saw given a matrix equation n many equations in a variable, we can always convert it into a metric system. Do so. What is the corresponding metric system for this? Is it correct what I have written? It is correct, right? Yeah. Please check. Please check. Is it correct? Okay. Now can you check if so what is the matrix A? This big 3 cross 3 matrix. This we are calling matrix capital A. Is this invertible matrix? Can you check quickly? Can you please check it? How will you check this matrix is invertible? Using yes. So please find out if the matrix is invertible. What is the determinant? Two, huh? Two, right? The determinant is two.
Yes. Yes.
Yeah. So this is invertible. So from above, sorry. So can I say, can we use this theorem to conclude something? Remember A is invertible. Determinant A means A is invertible, right? By this theorem.
Yes.
So what does point 2 tell you? That Ax equal to B has a unique solution. So which means yeah. So here also because determinant is non-zero, so this system has a unique solution. Am I correct? So we can find okay. So which means it makes sense to find the solution. Correct? See if there is any other way with the help of which we can ensure that there is a solution, then first we must do it, correct? We should not, we do not want to deal with the system, do all the computation only to find out later that there is no solution. Otherwise, it will be waste of our effort, correct? Do you understand what I'm saying? If there is any chance of making sure that the matrix, the given system has a solution, infinitely many or unique solution, it does not matter. If it has a solution, then only we should proceed. Correct? Otherwise, it is just waste of effort. Imagine, you are to crop a field, but the land is barren. Will there be any usefulness of your efforts there? So determinant is non-zero, which means the system has a solution. Now let me introduce some notation. Row operation, all of you know. So you know this notation: R subscript j goes to alpha times Rj plus beta times Rk. What does it mean that we are replacing this jth row by the row obtained by adding alpha times jth row and beta times kth row? Correct? All of you know this? Yes. Okay. Now let us do the. So what should be the first row operation? Can anyone tell me? Yes, R2 goes to R2 minus R1, and we can do two operation at the most simultaneously. What about R3? Yes. So can you do and tell me what will you get? Do these two row operation and tell me the matrix. Okay, one. And on the right hand side also you have to make appropriate changes. Am I correct? So you have 2, 5, 11. After these two row operation, please tell me how will you, what will you get as the next step? So do all of you get this? Please check. Is this correct? Uh, okay, Anuj is saying it is correct. Biswajit, Vishwajyoti, Bala, is it correct? Please check. Take your time. So and now, what should be the next row operation? No. Very good. Yes. You change R3 goes to R3 minus R2 and tell me what will you get. Yes. Hmm. Hmm. Again, you are forgetting something. Yes. 2, 2, 3, 4. Right. 7 minus 3 is 4. Yeah, yeah, take your time. Okay. When I was in, I'll tell you what to do. Okay, okay. Once you're done with this competition, tell me. We will have some non-mathematical discussion. Okay. Once you are done up until this step, tell me. Okay. Is everyone okay with this up until now? Okay. So let us have some non-mathematical discussion. So can you tell me about yourself? Like from where are you and like yeah. So okay, let me start. I have mentioned this, but as most of you might not know, my name is Nitin Tomar, and I am a fifth year PhD student in the Department of Mathematics, IIT Bombay. And why I am presenting NPTEL TA-ship, because the fellowship that I have been provided with, it is an integral part of that fellowship. Okay, and my area of research is operator theory, which means deal with operators which are infinite dimension version of matrices. Yeah. Anyone wants to tell about themselves?
Sir, I should all, actually, I am in a teaching position currently.
Oh, okay.
I am wanting to
Mm-hmm. Oh, okay. Where in Nepal? Ah, okay. Kubhal. Ji. Okay. And Anuj, which university? Oh, okay. Okay. Mm-hmm. Good. So this, you are a 30 basis student?
Yes, sir. Third year.
Okay, nice. Okay, good. And how about the two others? Namaste. Okay. Oh, okay. Nice. Sorry, I could not get the last sentence. Oh, okay. Okay. And what about Vishwajyoti?
I like myself the research.
Mhm. Oh, wow. Mhm. Ah, okay. So, okay, so we have quite a what should I say? What should be the perfect term for this? Quite a diverse group, right? All of you agree, right?
Yes, sir.
Yeah,
Yes, sir.
yeah. So
In various areas.
from various areas, but all wanting to learn mathematics. That is one common thing in all of us, correct? Yeah. So,
Yes, sir.
you can
Including
always
that.
take my name. That is, I don't know. You don't need to call, sir. So just take my name. It's fine. Right?
Sir, what is your full name?
My full name is Nitin Tomar, and I am from Delhi. For the past 4 years, I have been in Mumbai for my PhD, as I mentioned. So yeah, it has been quite a time. Yes.
You connected with
Uh, because as I told you, my area of research is operator theory, and I did Prime Minister's Research Fellowship. So, as a part of that fellowship, one integral duty that we have to perform is to do some teaching in a local government college. Okay, or via NPTL, you can also do it. So I chose I always choose NPTL, and fortunately enough, I got NPTL this time. So yeah, this is how I got this TA duty. Are you?
enjoying it.
Yes. Last time it, it has been a learning curve for me, for me also, I would say, and that is why I keep on asking. If there is any comment or if there is any doubt, we should discuss it among ourselves without without any fear. And as long as we are doing that, I am always enjoying that. Because we all are here to learn maths. That is, I find very interesting. So maybe we should learn maths. And if you find it I'm going too fast or too slow, then please tell me. Okay. So my aim, okay, I will tell you just one more thing. My aim as a TA, because all the technical details you will find on the during the NPTEL lectures, you can see and find. Correct. My aim here is to give you some introduction to what goes behind those numerical techniques. Do you get my point? Why a certain, for example, in the future, we will be learning Newton-Raphson method, secant method, fixed point algorithm, fixed point iteration method. Rangekutta, certain order methods, then Lagrange interpolation formula. But if you see numerical analysis, as most of the time it is seen as a very plain subject. It is a subjective formula. So you remember the formula, you perform the computations and the calculations, you will get the answer. But no subject has development in this order. Am I correct? Something must go behind all these things so that these algorithms are working. Correct? So what are the algorithms? That is my aim to tell you in the in the this discussion session. That is why I keep on focusing on the conceptual part more, because computations you will always be able to do. All these numerical explanations you will find during the master's lecture. You can always find. But what goes behind those algorithms is precisely my aim. Is at least to make an introduction to you what goes behind. We all know what is there. For example, this theorem we know determinant is non-zero if and only if it is an invertible matrix. But why and how it is used in Gaussian elimination method, I just want to make sure that all of us know. Okay. So again, I would like you to have some comment about how this is going. If you want to include something else, because this is again a learning curve for me also, as I said. Last year I took, and it was fine. But this year, because many students are attending, it is always a good idea to have your suggestions also. You can tell it right here, right now, if you want. And some of you are very senior to me, so please, I would be, I would really love to know if there is some comment you would, tell me, okay, you need to do this correct, you need to do that correct. So please tell me. Otherwise, we'll go back to questions.
whatever the presenting here, and that I must be.
Yes. Hmm. So what is? No, I did not get. Can you repeat? What are you trying to say?
Sure, we are attending a particular course.
Yes.
Its name is
Mm-hmm. Yes.
actual assignment.
Mm-hmm.
We have to submit it within a specific time.
Yes.
Whatever you are going to present or whatever you are discussing here, if it goes after the text of the video out of the material we have to provide it,
Okay. Okay. So maybe from the next time we can include more questions rather than the theory. This is what you want to say? Sure, sure. Okay, okay, okay. Uh, but in the beginning, what I'm trying to say, in the beginning, let us just make a strong base. I I have no from my experience, what I have seen, if I start discussing questions, then it all becomes like do this and that, do this and that. The aim is not to just solve the questions. The aim is also yeah.
but things that within the stipulated period of time,
Okay. Yes. Okay. Okay. But the current assignment I am not supposed to discuss. Okay. Maybe what I can do, I can find some previous year assignment of this course, and then maybe we can discuss that. Is that will that work? Yeah, yeah. Same course, but different questions related to what is going through. Okay. Okay. Okay, I will keep that in mind for sure. Thank you, sir. Okay.
So, sir,
Yes.
sir, if this means that taking Python coding anything, sir,
Mm-hmm.
would how to write Python coding in the
Python coding. See, the Python part you have to learn from the video lecture part only. See, why I am telling you, because I have been asked to discuss this course in a fixed way from the instructor. See, okay. So coding you are having problem with. See, again, another thing is, so there are some. So as you know, every because I am a teacher, maybe you can write my email ID and tell me what exactly your problem is. Will that work? So let me just share my ID in the call message. Will that work? So this is to all of you. Even if during the week you have some doubt, you please mail this. Mail your doubts to this ID. Did everyone receive this ID? Okay. Okay. It is gone. Let me just write it again. Is it visible now? Yes. Yes. So what all of you can do whenever you are having some doubt, in any particular topic during this course, you can just mail it down. Okay? Because this way we will be connected throughout the week, not just you know one day, 2 hours a week. Will that work? I think this will work better, correct?
Yes, sir.
Yeah,
Sir,
sure. Yeah, you will just write down your problem, and then maybe we can discuss this during this session.
okay, okay, okay.
Then I think this will be better. Because then we will be discussing what your real doubts are rather than telling that something comes in from my mind. Is it, does it make sense? So what I'm trying here, you mail your doubts to me, and then during the next, whenever we have the next session, before that you accumulate your doubt and mail, and we will discuss those one by one.
One thing is,
No, it is m dot TOMMY 01. Yeah. TOMMY 01. Yes. Okay. Let us go back to the question, otherwise time will be finished. So now this has a particular good upper triangular form, correct? Is it correct? You can see. So can you find out the values now? So remember the question was to find the value of x, y, and z such that this three equation hold. Now we converted this using the row operation and we reached this finally. So can you tell me the value of z directly? 2, correct. What is the value of y? 3. And what is the value of x?
minus
No. it is minus 3, right?
Beautiful.
Do all of do all of you agree with this?
Yes,
Okay. So what we did, step one, we converted the system into the upper triangular matrix, correct? And step two, we did the backward substitution. Why backward? Because we computed the last variable first. We got the value z first, then y, and then x. So these two steps are what form are what we know as the Gaussian elimination method. So there are few questions that you should ask yourself. Number one, why whenever we are doing raw operation, why the solution is not changing? Do you get my point? See, we are applying row changes, but why does it mean that the given solution should not change? Is the question clear to all of you? At every step, we applied some row operation and converted a given linear system into another linear system. But the real question is why do we have that these two linear systems consist of same solution? So what I want to say that the solution is invariant under row operation, correct?
yes, sir.
But why does it happen? That is my question. And that is a very natural question to ask. Do you get my point? Now the second question that can be asked is why are only we, why not go to the we have completed this row operation as soon as we get the upper triangular matrix. But why should we stop at upper triangular? We can convert it. Can we convert into diagonal? That would be my question. If we can convert the system into diagonal, then it will be easier to obtain the solution, right?
There is
Yes, yes, exactly, exactly. So I'm not explaining the general algorithm in Gaussian elimination because we already know that. Let us just see for the n equal to 3 case. You have three equations R1, R2, R3 are the first row, second row, third row. Now what is step one? If A11 is non-zero, then you divide the first equation by A11 and then you obtain a new system. So do I need to explain the general algorithm or is it clear? Okay, I think it is clear. If not, then you please tell me. I will share this PDF with all of you on the given link. Yeah.
how to convert it.
Yes. 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 Because as as soon as you get upper triangular matrix, you can always get the solution using backward substitution.
Yes, sir.
But numerically, this method is very costly, and we will see some drawbacks. So drawback is, this method can, for example, if you have zero here, for example, if instead of 1 in the first row, first column, you have 0, then this method won't work, correct? So, yeah, say,
And
those conditions, and you must have definitely seen in your video lectures, right? But see, the point is, Whenever you have a zero, you have to put a certain condition, which means you cannot deal with all the systems. Correct? Whenever you put some condition on the system, what does it mean? That the method that you are suggesting does not work for all the systems.
Sir, you wanted to discuss regarding the invariant of the system under
No, that is your exercise. That is your exercise. Okay. I am telling you right now, where does this method fail? Can we apply this method to every system? The answer is no. For example, if your first column is zero, then you cannot apply Gaussian elimination. If the first entry is zero, then again you cannot apply Gaussian elimination uh, because of the algorithm that we have defined. So all these things comes at a cost. So for example, you consider this example. You consider the following system of equation given by 0, 1, 1, 1, x1, x2 equal to 1, 2. You know, because a11 is 0, so Gaussian elimination, or the which we commonly call Gaussian elimination, is also known as naive Gaussian elimination. So this method fails. Why? Because the 1, 1 entry is 0. Another example I will give you. Another example is about the perturbating the system. You consider this system. Is the system visible to all of you?
yes, sir.
So if you consider this 2 cross 2 system, instead of 0, I am taking some epsilon very, 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 very small. Now since epsilon here is non-zero, you can apply the step 1. And then you will get something like this. Epsilon 1, 1, 0, 1 minus epsilon inverse, 2 minus epsilon inverse. And backward substitution will give you that x2 is 2 minus epsilon inverse by 1 minus epsilon inverse, and x1 will be epsilon inverse times 1 minus x2. Now, if you see, epsilon was very small, but epsilon inverse is very big because their inverse is very big, right? If epsilon is small, then its inverse will be very big. So, what I'm trying to say here, one obvious choice how to deal with this example could be, instead of zero, you approximate zero by a small number. Some epsilon you replace it, and then you will also kill that epsilon in the solution as we do in the analysis. Zero is the problem, right? So make it non-zero by constructing a sequence converging to zero. You just replace the zero by some small epsilon. This could be a very well line of thought, correct? See, what is the problem? Zero, correct? Yes or no?
Yes, sir.
Now I want to make it non-zero. How will I make it non-zero? You are a student of analysis. Tell me, if something is zero, what can I do? I can always approximate it by a sequence of non-zeros. No, no, no. We are not doing that here. Okay.
If everyone is good,
Yes. See, we can always do that. But the algorithm that Gaussian suggested, we have to stick to that. We are not supposed to replace any row. We can just add something to that row or subtract something from that row. Okay.
okay, yes, okay.
See, think like a computer. Don't think like a human being when you're learning numerical analysis. In some sense, what I'm trying to say, whatever algorithm you are presented, if you're a computer, you will not do the row change, right? Because the algorithm that I am representing, you should follow this. Do you get my point? Computer works on a certain set of operations. It cannot think independently. Right now, we are in the verge of that, I think. But then, whenever these methods were developed, they were thought they were applied to a computer. So a computer does not have any independent thinking. So whatever algorithm I will provide him, if I say, divide two numbers. If I give you two number A and B, then do B by A. So it will only do B by A. If I give 0 and 1, then it will do 1 by 0 and it will say not defined. So this is the same thing happening here. So this example says that even 0 you cannot approximate by, just a minute, where did this go? Yeah. So if you try to approximate 0 by some, oops, ये क्या हुआ? If you try to approximate that 0 in the A11 entry by some epsilon, you can always do that, right? Conceptually, you can do that. Um, are you following what I'm trying to say here? But yes, exactly. This is what we have been discussing so far. Even you can replace this one entry by very small number epsilon, but then error will become very large. You see the original solution, which is given in the square bracket, will be x2 will be 1 and x1 will be 0. The original solution, the when a11 entry was 0. But if we follow this epsilon approach, this system has solution x1 as 1 upon 1 minus epsilon, which is almost equal to 1. Right? So in this case, you cannot expect perturbating a system. Perturbation means adding some small weight to a given data. You cannot do that because then solution will vary. Solution can have very huge error. So in this way also Gaussian elimination fails. We will discuss about your doubts from next time, and we will finish Gaussian elimination some more key points in the next session. Okay? So I think we should stop here. Yes?
Hello.
Yes, yes.
We are talking
Exactly, exactly. This is what I have been trying to tell you. This is where, this method fails completely. You see, the idea was to, just a minute.
whether
Is it visible? I don't think it is visible. Okay. Yeah, please say.
bias is sometimes is right.
Oh, maybe some system problem here, internet issue. Yes, please. Yeah, please repeat.
Sir, my question is whether if A11 equal to 0 or A11 tending to 0, in both cases we are not getting as such nothing. We are getting as such nothing.
Yes, we are getting nothing from Gaussian elimination. And remember, this is one of the easiest system, correct? This is 2 cross 2 system.
Yes.
So even with this machinery, even with this method, some of the easiest system might fail. But numerical analysis does not, what should I say? Numerical analysis is more focused on what system does it work. It is like that kind of positive attitude that is built here in this course. There are many methods that we will develop here to study different cases and in different context. But why are those methods still popular? Because they work on a certain set of systems. Okay, and we anyhow numerical method does not work with every system. That is always a hard truth, and they will always give you some error. But in the real life, one can live with some window of error. Okay. So this we will see maybe in the next class. Okay. Okay then.